A question like this is not uncommon on the SAT for a medium or even a hard question. And what I want to talk about here is not so much the dangers of the two-step approach, which we've just covered, but another trap that test takers can fall into when trying to solve these questions. So here we have a coin collection. The number of coins increased by 20% over this year. And at the end of that year, Samantha has 252 coins. And we want to know how many coins she started with. So kind of sketch out the scenario here. There's some number of coins, we'll call it X, at the start of the year. And then over the year, that number will increase by 20%. And we end with 252. We essentially need to work backwards to figure out, well, where did she start? If she started at some number which increased by 20% to become 252, what was that number? And the trap, the very typical move that some test takers make here is to reason not without cause. I think there's some logic to it, even if it doesn't work out, to say, well, look, if I increase this by 20% to get to 252, what I need to do is decrease 252 by 20% to get back to X, right? Kind of like a round trip. Up to 252, back down to X with this 20% increase and then decrease. There's a logic to it, but unfortunately it's not going to work. But let's see what answer we would get, right? We would do our 252, and we're going to use our percent trick from now on, of course. So we're going to multiply this by 1 minus 20%. 1 minus 20% as a decimal. In other words, we're going to multiply our 252 by 0.80. And when we do that, we're going to get 201.6. So you might think that's 202. Probably if there are choices, they'll have an answer like 202. And unfortunately, this is wrong because we're not allowed to do this, even though it seems like we should be able to take off 20% from 252 to get back to where we started. Percents don't work like that. And in a future video, I'll walk through in some more detail why this doesn't work, why it seems like it should and why it doesn't. But let's actually solve this the real way. And the real way is going to be, yes, use the percent trick. But the key is whenever you're using the percent trick, whenever you're using that formula, you need to make sure the calculation in that formula is based on what the problem actually says rather than a reversal or inversion of it. So this problem does not say anywhere that there's a decrease of 20%. It's an increase of 20%. So whatever calculation I make, whatever equation I write, has to incorporate a 20% increase. So how do I do that? Well, think about this. If I start with X coins and I want to increase my X coins by 20%, how could I represent that using my formula? Well, I just multiply it by 1 plus 20%. And the result of this, right, once I increase the X by that 20%, the result should be 252. And so what we've done here, if we just simplify this equation a little bit, is we've built an equation that we can now solve for X. And in these harder percent change problems, it's going to be all about building an equation. Really, any hard percent problem can often be solved by building an equation, because then once you have the equation, it's just solving a simple, one-step or multi-step equation, and that should be pretty doable. But building that equation is the key, and you want to translate what's in the problem into that equation that you can solve. So we'll go ahead and divide both sides here by 1.2, and we get 210, which is correct. Now, if we took our 210, just to check our work, if we took our 210 and increased it by 20%, if I multiply it by 1.2, we get the 252 that we would expect. So either way, we should get 210.